Hello, everyone. Welcome to another of the Heliospectra webinar series. And we're very excited today. Once again, we are here to give you some more information during this pandemic so that you can self-isolate, socially distance yourself, but still keep informed and keep connected to the cannabis community and the horticultural community at large. Today, we got two amazing experts to share their stories around how best we can accelerate cannabis production from seed / clone to harvest. And I should have introduced myself. I'm Av Singh, a family friend, I believe, of the Heliospectra family. I'm always happy to be working with Heliospectra, and I think what I really like about this this webinar is that we've got two companies that both deliver amazingly great products, but it's actually the customer service, it's the expertise, the technical advice that they provide all of their clients. That's why I'm really happy to have both Heliospectra and Hanna Instruments here. I'm going to turn it over to our panelists to introduce themselves, but I encourage all the participants on your screen. There's room for questions. We want to make sure that there's a good opportunity for everyone to have their questions answered. If we don't answer the questions during the webinar, we look forward to responding in a personal email back to you to have your questions answered. So without further ado, I'm going to turn it over to Ryan Wonkel and Mike Bogalewski from Heliospectra and Hanna Instruments, respectively. Ryan.
Awesome. Hello, hola, hey, aloha, bonjour, everybody. It is good to be back once again in 2021 for our Grower to Grower series. So thanks a lot, Av, for the wonderful introduction. A lot of you might know myself out there, but if you don't, my name is Ryan Wonkel. I am the cannabis grower liaison for Heliospectra. Heliospectra is an LED lighting solutions provider that started in 2006 by two plant scientists with one common goal, was to make crop growth more efficient. I myself am a second generation cannabis grower who ran multiple facilities here in the Denver, Colorado region from 2009 to 2015. A multi High Times Cannabis Cup winner. So I'm really glad and excited to be on to the webinar. So thanks a lot, and I look forward to the conversation. And I'll pass it over to co-presenter on the panelist, Mike.
Hi, I want to thank Heliospectra and everyone who's joining us today. Thank you so much. It's a pleasure to be here. It's very exciting. Collaborating with this team has been a joy, and we look forward to your questions today. We look forward to interacting with you and hopefully helping everyone grow a little bit better. Okay, a little bit about myself. I started with Hanna a long time ago, back in 1993. So I've been with the company and I've watched this company grow. It is a worldwide company. Many of you are familiar with Hanna. We started in 1978. And it's one of those $1,000 in the garage stories where this entrepreneur came up with a great idea and said, you know what, I'm going to make this happen. And Mr. Oscarnato, who founded the company, did make it happen. And if you ever use a pH tester, like a FEP or some type of handheld tester, that started with Hanna Instruments. We were the innovators. We brought that to fruition. Now many other companies make a version of that. So we progressed beyond that, and it was always Mr. Nato's dream to help the farmer, help the grower, and that progressed into process control and also testers and other types of lab and bench instruments, so we could simplify measurements. So a farmer wouldn't have to take a sample and send it to a lab. He could test immediately, something simple, something easy to understand. That was the basis for Hanna Instruments, to bring technology to the end user, to make it simple, affordable, accessible. right? Technology accessible. So with our passion as a company for growing, we started building how do we best inject nutrients, control oxygen, control a variety of things with water. With Hanna, it's about water. That's what we're going to talk. That's what I'm going to talk about today, is how to get that water from the source to your plants. And we have great passion, and we started out building fertigation systems. I've been all over the world. I've been fortunate enough to travel to Europe and watch how they do it. Watch how they were much more advanced than us in the United States, because of the space restrictions that they have relative to the US. So they had to depend on technology. They were way ahead of us. So I learned a lot from the Europeans on how to automate the whole process. And I kind of engineered a system back in the early 2000s, and it's basically grown or evolved into what we have today for fertigation. So we have an entire line. We produce everything here. Everything's handmade to order, and we service and believe in our customers. So I like to say these are my babies, right? So all these fertigation systems. So that being said, we take great pride in making sure what we put out there in the world works, and we're looking to partner with people to broaden our horizons so we can all bring you guys something very special as a team, as a group. Thank you.
Super. Thanks so much, Mike. That's very exciting. Yeah, it's so nice for me to even, remind myself that, Hanna is so much more than just a pH meter and a handheld EC meter. So I'm going to jump right into this webinar, and, I wanted to make sure that we understand a bit of a disclaimer here. Although we're talking about accelerating cannabis production from seed to harvest, we are not going to diminish quality. So I really want us to keep saying that if there is something that you're going to be recommending that you feel like, you may not get the same taste or aroma out of that cannabis, please comment on that as well. So the first question I want to ask you guys, in terms of going through the stages, we're going to talk about, germination, clone phase, then the vegetative phase, then the generative phase, the reproductive phase. Wanting you to kind of highlight some of the tips that you would recommend at each phase. So let's start with Ryan, and let's start talking about the seed clone phase.
Yeah, I think thanks a lot, Av. I think it's and it's the kind of the foundation, and I think sometimes the overlooked process of all of this, the cloning and seedling, and maybe it's just taken for granted that that it is a plant and it does adapt, and that 95% of the times you can take that cutting, throw it in some sort of medium, and as long as you have as long as you're not feeding it bleach or anything, and you have some water and some proper oxygen, kind of take for granted that it roots. But it also with understanding that that is also the foundation, can be the foundation for success throughout your life, whether it's going from the veg process to flower into your finished flower product, or possibly even that clone could potentially be the next mother for the next mother stock. So really, I think understanding that it can be potentially overlooked. And I think with all of these conversations, and a lot, of course, with myself and focusing and being an LED company, but I think in general, as growers, we've managed every aspect of the process from all of growing, from the cloning, from the in each environment of the cloning, and understanding the proper humidity, and that clone is not really transpiring so much, so you are going to have a little bit higher humidity, but really controlling every aspects of the grow, down to the nutrients for each of these stages, and then really looking at other ways of how can we get it even more precise. And so I think that even growers started to eventually look at aspects of lighting, and understanding, okay, very quickly on, although lights weren't really custom spectrum made for these specific applications, growers were really utilizing the technology that was out there, utilizing a very high blue light. We find that, in cloning and also in the veg stage, and growers instantly started to gravitate kind of towards the legacy of traditional lighting of the T5 bulb. But with that comes with another inconsistent amount of lighting, and an inconsistent amount of lighting is going to give you the inconsistent results of cloning. And I think that those are one of the attributes that starts to get overlooked into cloning. Having a proper light source, having the proper light levels for that cloning and for that specific application of cloning. A lot of the times I see clone areas are very typically underlit. Usually it's the last area that they have filtered their T5 bulbs, and those they're actually starting to fail, and they are just getting by. But understanding that this is kind of the foundation for success, that each one of these stages that we talk about really is going to amount to a really high quality product in the end. So I really look at, making sure that you're going to have proper lighting levels, consistent lighting levels into your cloning areas, of course, is very consistent and key.
Do you feel comfortable kind of stating a photo period that you like and PPFD level?
Yeah, totally. And I think it goes back to your kind of application and purposes. Typically, we find it, Heliospectra, we will recommend anywhere between 75 to 150 micromoles ppfd of light onto that clone canopy, and that will be for an 18-hour on photo period. Typically, I don't recommend growers go into a full 24-hour period. Although cloning, you do see that fairly common in the cloning practices, but we do recommend going with an 18 on and a 6 off. And then also, I think to take it to another level is really, with the LED starting to come onto the market, is having an actual quality spectrum that's actually going to promote healthier root development, faster root development, for that plant that's going to be ready to take off, less stress going in from that transplant. So having a high blue light, of course, a balanced spectrum is important all around, but a spectrum that's a little heavier in blue, we find really promotes a nice, healthy clone ready for transplant.
Great. Let me throw it over to Mike to talk a little bit about nutrition and fertigation or irrigation on clones.
Well, again, my emphasis is how do I get water with nutrients most efficiently to your plants, and also controlling the pH and alkalinity of that flow, right? So when we're dealing with clones, especially, we're dealing with dilute nutrient solutions, right? So we want to make sure we have a system in place that's going to first and foremost allow us to control, small amounts of additions or small additions of nutrient, either through micro emitters, sprayers, however the grower chooses to water, in some cases even by hand. But it's very important at that early stage of development that we're able to tune in the right proportions of nutrients. And it's also vital that we look at our pH of our water, our alkalinity, and it all goes back, if we rewind that a little bit, it goes back to what is your water source? What does that come down to? How are we dealing with an RO system? Are we using UV, carbon filtration, of various degrees of filtration? Are we coming right in with a municipal supply that may be fairly clean? So we have to be very careful and extremely precise with the way we distribute nutrients, especially in what I call that dilute phase. Okay, and the flexibility, again, to be able to change on the fly the nutrients that we're delivering, and maybe even some micros, and change those constituents. So again, you're dealing with 100 parts per million, maybe up to 400 parts per million. That's pretty dilute. So we want to have some significant control over that if we're automating that process. I think that's vital.
Great. Okay, let's move on. We're moving into the veg phase. What do you think, Ryan?
I mean, it starts to go back with lighting, and then it also starts, for me, I start to reflect on, sometimes why that clone stage, is going to, kind of add on to that clone stage of, why it starts to become overlooked. And, typically we are looking as, we're very visual people, and typically when we're looking at any sort of farm production, it's usually our number one go-to when it comes to scouting any sort of monitor any sort of growth aspect into your grow. And I think the reasons that cloning is overlooked is that there's not much visually happening. That I think that the veg stage is the first, start of the process where you really start to notice anything of any sort of stresses that have started to be induced, any sort of growth characteristics that you actually have going on, any nutrient deficiencies. So this is really the first element where I really start to heavily promote scouting into your garden and actually close monitoring, because your crop's going to be able to tell you a lot. And now be able to, since you're being able to monitor every aspect, and now that you do have the ability to monitor even the aspect of a specific spectrum, maybe even for a specific chemovar that you might be growing, if you are utilizing a solution like Elixio with spectrum controlled, versus a Mitra solution that might be only the dimming capability, where you're really dealing with photo period and actually the quantity of light that's coming out of it. But you are now actually getting all of these consistent aspects that you can control, even lighting. And that comes, of course, with your consistent, which Mike will sure talk about and touch on, consistent options of fertigation. But for me, that's what I've always looked for, are all these consistent elements working kind of hand in hand together. And then, of course, utilizing what the crop is telling you. So I always am looking for, visual signs that are usually the go-to for growers to go into. It's not sometimes the most reliable, but visually going in there and looking at your crop. Is there yellowing on the leaves? Where is that yellowing happening? Is it happening on the lower part of a plant to a mobile nutrient, or to an immobile nutrient where that might be yellowing at the top? How that actually yellowing is happening. Is it happening, from the veins of the leaves? So really closely monitoring your plants and scouting is, really, good tool. And usually the color indicators. Of course, the vibrancy sometimes of the plant. I mean, I think we all know as beginning crop growers, it's sometimes as basic as does the plant look like it's drought and it's shriveling up because there's not enough water. I think it's the first sign that we all look for. But as a grower, can you see that sign happen before it's starting to happen? If you're introducing, and we'll talk about some drought stress probably in the more of the flowering segment, but really closely monitoring the plant. And I think that that's the first element that you're really working with in the veg. And then not being, utilizing some other tools maybe out there in the market, resources like leaf analysis. And
Sure. I did want to, and sorry about this. I felt like in the clone phase, I didn't really prompt you to maybe give some more definition around, do you use a seedling mat, heat mats? What type of size clone do you take? Any of those type of attributes help in the acceleration of sort of that seed to harvest that we're looking at?
Yeah, I think that's a really, really great question. For myself, I think it's going to be based all around that there's going to be different methods that kind of fit people's different kind of cultivation skills or potential their different needs or how they're rotating into their garden. I typically find that there is a balance between, having this massive clone, that I see that people try to take this, I mean, it looks like a month-long veg plant or 2 or 3 week long veg plant, and there is a process of that plant having to convert its that vegetative to going into creating roots. So I find that there is a sweet spot for myself. I find between 6 and 8 inches is roughly, or really, 8 inches is even on the taller side. Usually it's about 6 inches is a pretty good clone size. If you're cutting and using, say, an easy cloner, of course, you're going to have a little bit of the extra stem to go into the collar and then go into the actual mister. I myself was using some plugs. I think some of the common mistake is density, and I try to get people from going from this really packed clone trays. giving your plants a little bit of time to have a little space, especially if it's underlit. So watch your density, and if you're, let your plants root or grow, that's really definitely give your plants a little bit of extra space. I do some cropping of the leaves, and I think that is for myself. I've always thought it's always to help lower transpiration. There are some white papers in the industry that shows that's not necessarily the case. For me, I do feel that it still helps into my process, and more probably space mitigation and giving a little more space in those cloners.
Sure. Yeah, I apologize. I know we're going to the vegetative phase. Mike, do you have some comments around the vegetative phase and how you orchestrate your nutrients to try to move that plant forward?
Again, I would say this, it's an important stage for feedback, right? That's when we're going to start listening. Okay, and I think that, and I should rephrase that, maybe start listening on from an automated perspective, feedback from various types of instrumentation. We want to know what's going on in that media. Okay, we want to know what's, we want to look at the indications on those leaves, but we also want to monitor the environment. We want to make sure our lighting schedules are what they should be. We want to make sure that our relative humidity is what it should be in the room. We want to make sure our moisture sensors and how they're spaced are going to trigger us to a watering schedule or maybe an emergency watering cycle if necessary. So all of these things, maybe the light detection. Okay, these are all sensors and tools that should be employed in this stage of growth. And again, regarding your leaf conditions and the indications, maybe you're lacking in micros, iron, or whatever it may be that may be stressing the plant and causing discoloration, you want a system that's going to be responsive. You can't work with something that's going to work in ratios that necessarily, well, you can, but maybe you can do better. And you want to work with something that you can walk up to, that's intelligent enough where you can type in, hey, look, I like to kick up, my phos or my iron additive, maybe 2 or 3%, right? It's hard to do that with a volumetric dosing unit. Okay, so that's the type of precision that a good injection system that's intelligent, that is, it falls in the line of CEA, right? Controlled environment agriculture. So we want to now, at this stage of growth, at every stage of growth, but primarily at this stage of growth, it's very important. We want to take information in. We want to automate that information. We want to change what we're going to do and how we're going to introduce those nutrients. Okay, because at the beginning of the veg stage, we're still kind of dilute, we're picking up, but we want to have that flexibility so that the system is responsive enough throughout the growth cycle to change the amount and volume of nutrients that we're adding on the fly, and also that pH of the water. And there's other various things. I think in flower, we want to look at oxygen. We want to look at it now, but we also want to look at it then. As we're adding more nutrients, the salts have a very large ionic radius, so they tend to push out other things like oxygen. And it's important to introduce dissolved oxygen into your irrigation system as a component, so that way you can strengthen that root zone's resiliency and its ability to absorb oxygen, not only in the media, but also help process that nutrients and allow that root system to uptake those nutrients more efficiently. So all of these things are very important. We're getting in, and I can't stress enough, we're getting into that feedback stage. You want to look at your RH, you want to look at your temperature, VPD. You want to start really thinking about this stuff, how it's all intertwined and integrated. Okay.
You want to throw out some parameters that you feel comfortable in the vegetative stage around RH, around temperatures, or is that too specific?
Well, I mean, your light cycles, what you're talking, what, 12 hours a day to 16 hours a day. And Ryan, please interrupt me if I'm mistaken. Your RH levels, probably about 70 to 80%, if I'm not mistaken, as well. Now, that may differ from one facility to another slightly, depending on what you're looking for. Your concentrations of nutrients may be, 300 to 400, and you're increasing your total parts per million in concentration. Your micronutrient regimen may be expanding, so you may be adding more micros at this point in time. So that's what I would say, and it comes down to the grower too. I mean, there is a science to this, and there are common traits, but also every grower that I've worked with in 25 years, they're artists. They really are, and they tweak these parameters and they push these parameters, and they also introduce a variety of different feeding schedules. So we have to have a system that's responsive to that. And it's not necessarily what I know as far as the specifics of what the grower is doing. It's, can I provide something that will allow that grower to do anything that he or she wants to do, and to adjust any particular parameter.
Great, thanks. Okay, we're getting into that flowering phase. We're entering into that. Ryan, do you want to give some tips on how you can accelerate that process? Temperature, humidity, lighting?
Yeah, definitely. I mean, it's kind of this whole symbiotic relation, I think, between all of these. And, Mike touched on, a lot of good points that, for myself from a grower and looking into these, reliable, anything that's going to provide reliable and consistent results, whether, it's feeding, different lighting, is all going to be really key when you're looking to rapidly performance, cannabis flower. The first thing that I tend to go to if people are not looking into CO2, of course, going into CO2. It's a fairly simple thing to be able to add, but with going into CO2 becomes to another element of, do you even have enough light? Is your vapor pressure deficit, which is probably one of the most important factors of growing, are all these parameters going to be met? Because adding more light is going to increase your grow. Adding the right kind of light, of course, is something that I'm going to, recommend. Us at Heliospectra, we provide far red, and we find that, we do have growers that can decrease, their time to harvest anywhere between 5 to 14 days, but very strain dependent with that far red. So having the right spectrum is very important, but also having, all of the right environmental parameters that come along with that. Because just if you're providing more light, is not going to necessarily equivalent into more yield. So looking into all of the sources, as Mike mentioned, the automation is going to be a lot of your times your best friend in the high performance cannabis environments. Because you can, you need these sort of tools to be able to set these parameters, to be able to work with you and not against you. If you are providing more light, you do need to provide enough CO2 into the room. If you're not providing enough CO2 in the room, there needs to be, these sort of backup systems where you are alerted that, either it needs to be changed, but, having these tools are going to really help you into these environments. Spectrum, obviously, I kind of have mentioned onto that. Far red spectrum, we feel that it is essential for flowering crops. It is naturally into the environment. Cannabis is naturally evolved with far red. If you're not familiar, with far red, it is, really just a kind of what they'd say a shade wavelength, that it is, produced from natural shade environment where you are going to have higher proportions of far red. So, thinking about where a lot of these strains and chemovars have came from geographically, that we do find that having the right spectrum for each, and this goes for each of the stages of growth, that having that higher blue in that clone stage to veg is going to, promote a shorter veg time, a plant that's more robust, and then going into that flowery environment, giving it a little bit spectrum that's still very broad, but a little bit higher in red and also far red into there. And then of course there is the, the driving of, different growth attributes through nutrients. So, really when you're starting to fine tailor that, but I think that that's kind of the process of, how you're utilizing. Are you, going with a living soil, then you're going to make sure that all of those parameters are going to be met for your living soil with pH, and making sure that all the microorganisms are of course being taken care of, and that soil is not going to dry out to harm all of those, versus really tailoring and really getting very specific with some of liquid available nutrients, through a really accurate fertigation system. All of these parameters really work hand in hand, so key when it comes to flowering, and especially trying to really accelerate any sort of flowering growth.
Great. Mike, do you have much to add to those comments in terms of fertigation?
Yeah, in the flowering stage, again, going back to what we talked about before, feedback is important. We said in the early stages of growth, we're looking at, like, say, RH, for example, we're looking at 65, 70%, somewhere in there. But you don't want to go in the flowering stage above 60 too much. So it's important you maintain humidity and temperature, and fluctuating your temperatures appropriately, right? And at the late stages, all of these things are important. So, your watering also becomes important. That contributes, along with your temperature, to the amount of moisture the air can hold. So that's just one example. Now, going to nutrients specifically, again, in this stage, we're watering where maybe our nutrient schedule is different. We have to be very cognizant of our salts, right? And oxygen, again, I can't stress enough, is very important. So we want to have a way to oxygenate, to create dissolved oxygen in maybe our RO storage tanks, maybe somehow introduce that through a Venturi injection system in our line. Another thing we want to be cognizant of, that I haven't mentioned, I'll save for this growth stage, is that the types of fertilizer we use, right? Organic versus inorganic. So we have to be somewhat cognizant of that, and I think that's very, very important, and I will mention that here as an overview overall, over all of the growth stages, right? What is the difference, really, when you're dealing with certain types of nutrient injection systems? Well, EC is electrical conductivity, right? So basically, salts are ionically charged, right? So we read this charge in the water, and it's directly proportional, we hope, in most cases, to the concentration of a particular constituent or a particular additive, right? Okay, so it's very important that, and that's our detection, that's our mode of detection, so that's vital. Now, the difference with organics, depending on some types of primitive organics, crushed fish heads or crushed waste or whatever it may be, those organics may not present an EC at all, or an EC that is really not directly related to what it is you're trying to get out of that, right? The nitrogen, the phosphorus, okay, or potassium, whatever it may be, but you're not able to draw a direct correlation. So it's important to know, okay, I have this advanced system, but can the advanced system even see the fertilizer, the nutrients that are floating by? So it's important to understand the chemistry a little bit from a basic level. Ask the question, does this nutrient, does this fertilizer have an EC that is directly proportional to the concentration of that particular constituent or groups of constituents, if it's some type of combined fertilizer, combined nutrient, right? So that's very important. EC, parts per million, ratios, all of these things, try to understand these things. And the most advanced systems, the Hanna systems, I don't want to mention other companies' names, but the Hanna systems, and I'll the hell with it, Priva, Argus, Netafim, all of these systems use EC in conjunction with volumetric control. And so it's important to understand and to make sure that whatever you're using, it has an EC that's traceable, right? And, to me, measuring EC is actually looking into the water itself. It's like testing your blood, right? You wouldn't test your blood by feeling your pulse, right? You can get an idea, well, I'm alive, but I guess I got blood flowing by. So that's kind of like a volumetric injector to me. So you really want to get into the blood, see what's going on, and that's EC. And that's what's really, that's what's these more advanced systems are going to give you. So again, I would stress, again, feedback, RH, VPD, all of these things are important to feedback. Oxygen becomes vital because we've been using nutrients for so long. We have to flush properly, but we've been using nutrients for so long. We got to make sure we're not pushing out oxygen, right? And understanding our fertilizer from beginning to end, okay? Dilution, how to control it precisely is very, very important.
Thank you. Yeah, great.
Sorry, I'll let you continue, but I love how you stress about oxygen, because there's so many times that, when you're going in and you're using these reverse osmosis systems and you're stripping all of the oxygen, from that. And a lot of the times they go into there and not even a simple air stone might even be placed into that reservoir, and growers might be suffering from all sorts of issues. So great point on the stress of oxygen, Mike.
Well,
yeah, we'll talk more about RO later and how in pH and how that's related to. That's very, very important. So go ahead.
Sure. Maybe we can kind of jump to that, because you both have talked a lot about measurements, and you've talked about observing certain stresses. Ryan, you alluded to doing some scouting and making some observations on that. But what other tools do growers have to kind of find out if their plants are under stress? How do you assess dissolved oxygen, and where do you use these tools? So Ryan, do you want to maybe speak a little bit around some of the issues around some of the plant stresses that you see, and perhaps some of the tools that you use to address what you're observing?
I mean, you obviously have to have enough processes that are in place that are trackable, that, the feed, as Mike's mentioned too, is feedback is super important. Of course, you have, the more traditionalist things, I've mentioned scouting, but at a point of large cannabis production, you do have to utilize, the automation, the resources that are out there, whether it's a leaf analysis. Sometimes it's great if you do have a legal aspect of being able to actually take a leaf tissue sample and send that off to a lab, so you can truly start to see it from a chemical analysis. The first thing that as a grower that I start to utilize is, again, maybe it's the simple EC and pH pin that Hanna starts to provide, but the runoff is very, very key into any garden. And I think that you can start to tell a lot from your garden, of course, by a lot of these scouting aspects and elements, but then utilizing these tools of understanding the runoff. It's one thing of what you might be, injecting and putting into your plant from the very beginning, but when it actually is going through all the medium and through that root zone, how is that all being absorbed and connected? So I definitely encourage, of course, really monitoring your runoff in cannabis production for nutrient uptake, any sort of issues and problems. You can tell a lot from there.
Okay, so I'll jump in. Great points, Ryan. By the way, it's great to work with a team of people who are. It's just so much fun, that really know what they're talking about. So just want to add that. That was great. I would say, as far as dissolved oxygen is concerned, you can introduce that at various levels. I guess the most efficient way to do that would be in the storage tanks, and to create some type of circulator loop with either a Venturi injector. You can inject oxygen also, so that it bubbles up inside the tank. If you have tall tanks, 5,000 gallon tanks or 2,000 gallon tanks, whatever that may be, you're going to get a lot of hydrostatic pressure that's going to force that bubbling action at the lower level of that tank, especially if it's full. It's going to force that oxygen into a dissolved state. It's going to kind of saturate that water a little bit. So that's where I would introduce that. And you're going to get a lot more of that through the impeller of the pump that's taking that water out of those tanks and delivering it through the system. And if your system is pressurized at 60 psi or more, that pressure is going to keep that oxygen in that dissolved condition. So when it hits the root zone, it will degas, but you're going to get some into that root zone, and you're really going to help those plants breathe at that level. So that's very, very important.
What are you aiming for in the reservoir in terms of concentration of dissolved oxygen?
I would like to be, at 100% saturation or more, right? At hydrostatic pressure, 10 meters or more. So if you have a big, tall tank, you're going to get another atmosphere, right? So you're going to get 200%. So if we really want to saturate that water, we want to get between 100 and 200%, really get that in there at maybe 10 milligrams per liter, really saturate that at hydrostatic pressure. So that way we can hold on to that DO through the pressurized system. Now the pressure is going to help. It's going to help. That 60, 70 pounds is going to help. So that's several bar for our European friends, right? So that's really going to keep it in there, and eventually we want to get that to the root zone. So and you're going to get that through, it's kind of it's catch-22, right? Agitation will allow the oxygen to dissolve, but it also degasses it as well. But once you get that into a pressurized system, that kind of holds things in place. So we want to get that up above 100% if we can, right? So
great, super. You had mentioned about pH. Did you want to speak a little bit more around what you're looking for in terms of monitoring the pH?
pH is important. Most folks shoot between 5.7, 5.8, and 6.1, somewhere in there, 6.1. I would say with pH, it's an indicator, kind of like a speedometer, right? What you're really looking at and what you're really looking for is the condition of your water. You're looking at the alkalinity. That's really what you're looking at. That's as important, if not more important, than pH. And there's a correlation between your pH value and your alkalinity value, obviously, right? So, but not necessarily a direct correlation, depending on the constituents that are making that water alkaline or less alkaline, right? Is it calcium carbonate, bicarbonates, magnesium, sodium? So all of these combinations of constituents are going to change that alkalinity value, but may not affect the pH so much. So you could actually have a pH of 6.1 or 6.2 with an alkalinity of 70 parts per million or 80 parts per million. That may be perfect, right? So you want to be between that 70 and 120 part per million range. Okay, so that's usually the universal range of acceptance. So that way, at that range, the plants will uptake the most nutrients possible, the most efficiently. So alkalinity is, in my opinion, more important than pH. That really tells the story. pH is an indication of it, and easier to test in a process type of environment. So you use pH in process, you use pH in a pen. With alkalinity, you've got to react it with some catalyst chemicals to get that reaction. It's a titration. So there's a little bit more work involved. It's not as direct as pH is per se. As far as RO is concerned, here is the great catch-22, or if you will. RO water removes everything, in essence, right? It removes most things from the water. You're left with H2O, okay, give or take, right? At that point, you're going to say, wow, I got 7 pH, or I got a lower pH. I should have 7 neutral, right? Perfectly neutral. Well, you don't, because there's a lot of carbonic acid that's generated actually through the membrane, the processing through the RO system, that actually drives a pH of 6.5. Now you may get farmers looking at that and growers looking at that saying, oh, 6.5, I gotta be at 5.8. Wait a minute, no. Your water is corrosive as heck, right? It really is. You've got nothing in it, so it's gonna suck everything in, and you've got no buffering capacity. So here they are trying to inject acid to bring that 6.5 from the RO system to 5.8 or 5.7, and they're like, well, Mike, why do I add 1 drop of acid and my pH goes to 2? Well, because there's nothing in the water and it's becoming what you're introducing to it very, very easily. I don't necessarily want to use a sports analogy, but it's like an offensive line in American football, right? So he's going to put, that line is going to push back against the defense. Well, if that line doesn't exist, you can walk right in. So basically, I introduced 1 drop of acid into a pure water, a container of pure water. Well, that pH is going to drop. There's no pushback against what I'm introducing. So alkalinity is very important, and trying to really control the pH in an RO, direct RO line, is insane. Now, when you add nutrients, you're adding salts. You're creating a buffer a buffer condition. So now you can actually introduce that acid or base to tailor it just where you want it to be from a pH perspective, because you're getting that buffering capacity from the nutrients that you're introducing at that point. So now it's more realistic. But prior to that, don't do it.
Great, thanks. Okay, so I can see some questions being posed on the question tab. I encourage more participants to send in some questions. I'm going to just kind of allow a couple of last thoughts before we go to those questions about any other tips that you would really want to highlight when you're talking about this accelerating cannabis from seed to harvest. Any last little thoughts before we get to the questions?
Sure. I would say, Ryan, I'm sorry. Do you want to go ahead?
Go ahead.
You can go with you first, me. So I didn't want to cut you in line there. So,
go ahead, Ryan.
But I would say everything begins and ends with the heart of the system, and everything, in my opinion, well, I'm biased, but everything begins and ends with water. Water. Okay. Without water, there's no life. Okay. So the water coming into your facility and your irrigation system, how well it holds a fixed static pressure throughout your operating flow range, how well you clean it, or how much you know about the water coming in. Do you have your water report? Do you know what's in that water in the ground that's being pumped into your facility? That is your lifeblood. So that you need to know everything there is to know about that water coming in the building. And then if you're going to use RO, if you're going to use storage tanks, make sure you have the right capacity and 10 to 20% above. So you're going to grow and expand. So you want to make sure you don't size your system too small or inadequately. Make sure your pumps are right. Make sure you can maintain that static pressure. Pick a static pressure, depending on the system you use, maybe 40, 50 pounds, 45 pounds, 55 pounds at the fertigator. Make sure it holds that pressure perfectly throughout the operating flow range. So if I'm only drawing 5 gallons a minute, I want 55 pounds. If I'm drawing 25 gallons a minute or 50 gallons a minute, I want 55 pounds. No injector can work consistently. You cannot introduce nutrients into a pressurized line or into a line consistently and effectively if your pressure is all over the place. Imagine if your blood pressure was fluctuating all over the place all the time and you're just sitting here, right? So it's very important that you maintain that pressure. Very important, you know how your system works. If you get that system working perfectly and tuned, you will grow massive plants. And everything in your life, your quality of life, will be 1,000 times better.
Great analogy. Ryan.
Yeah, I mean, I second all of it. You know, consistent, reliable processes. Again, you know, being able to take in that feedback, being able to make changes, and being able to adapt. You know, it's obviously a lot of inputs that come into cannabis production, whether it's lighting, water, all of your basic nutrients, all your environmental parameters. All of this is a kind of a symbiotic relationship. When there are any sort of, you know, failures, there will be problems and issues. How you can mitigate those is key. I always say it's about being proactive rather than reactive. Having reliable systems working around you is obviously going to be key for success, whether it's, you know, consistent fertigation options that's going to, you know, do the same consistent thing. Consistent lighting options is another key. All of these are work all hand in hand together. And then it's just taking care of, you know, this equipment that you get to work with you, and then taking care of the things. There's a lot of the times when I go on site, I bring an EC and a pH pin. You know, how many times I go and see a pH pin that's like literally flaking off with chunks of white just coming off of it. And then they're showing me a problem with their plant. Well, it's, you know, a pretty easy mitigation at that point. So relying on your systems, and when there are problems, being able to go back to be able to check your processes and see where there might have been a point of failure.
Super. Great. Mike.
And don't be penny wise and dollar foolish. Spend the money to buy the good system up front, because you'll be spending more money in the long run on help, on your time and effort being in there for 12, 13, 14, 15 hours running around chasing problems. Don't be penny wise and dollar foolish. Get the system, get what you need. Your life will be a lot easier and you're going to grow great plants.
Great. I think that that last point really speaks to some of the questions that we're getting in. And what I like about these questions are, I think they're the typical question that I think both Hanna Instruments and Heliospectra face on a daily basis, where their clients are just asking them a question, and this is the type of technical advice you'll be able to provide them. The first question I see here is probably related more to Ryan. It's a question perhaps to deal with maybe the Elixia Light or something like that, because it's talking about what percentage of the 660 nanometers is used with Heliospectra. This person says that they've been using about 40% of the total spectra at 660 nanometers. So I assume this is in flowering. You were talking about the far red. What would you kind of recommend?
Yeah, if we're talking about the 660 nanometers, we're really looking at the red. So that is before the far red region. So that is going to, primarily drive synthetic production. So in the red stage, we typically do recommend decreasing that 660 channel to actually about 40, to run about 40% total of that channel. That actually kind of raises that blue to red ratio in the veg application. In flowering, you can actually start to increase that 660 channel. And sometimes, as you mentioned at the beginning, Av, about with the focus on quality, you can start to, implement some of that red differently. A lot of growers we find will run, especially on that mid flowering, right in that, day 18 to day 35, they're running a lot of 100% of those channels. Including the far red. The far red, particularly in our lamp, is in the 730, 735 nanometer range. So if you're utilizing that and have that in the Elixia lamp, I do recommend starting to implement that 730 nanometer in the flowering stage. It does depend on strains when you start to apply it. But again, right around that day 18 and after those initial stretches, I do start to recommend on a 100% channel, at least for starts to be a majority of that day. You can do some sunrise and some evening and some end of day exposures with the far red. I recommend checking back on some of our previous, Heliospectra webinars where we really have taken a deep dive in some of the spectrum.
And I just got some clarity on the question. It was actually around the clone stage. So you had mentioned that in the clone stage, you like to have a fair percentage of blue, but where would you keep the red?
Actually, so for the red, we find growers, I'll actually reduce it down to 125. It's basically about 12.5%. Or 125 out of the 1,000 if you're, looking at our Elixia model. So I would actually recommend decreasing some of that red out. We do have some growers that do not utilize any of that 660 channel, but also keeping in mind that when you're decreasing or increasing in any of the channels, that you really want to monitor your light levels. So if you were to decrease some of that 660, you will start to decrease your overall light intensity in that area. So you might potentially need to drop the lamp. So there is a balance between that. So always keep that in mind.
Great, thanks. All right, the next question is for Mike. It's I think a pretty simple question here on finding out they're finding a little bit of crystallization in their pen in their storage solution. So do you have any tips on how to avoid getting any of that crystallizing in their storage solution of their pen?
You won't. Okay. Just a quick background on pH electrodes. The pH electrode is kind of like your car battery, right? There's two electrodes and it's in a concentrated acid or salt solution and it creates a voltage. So your pH electrode kind of does the same thing. It's a galvanic cell. It spontaneously reacts with salt reagents and creates a voltage output that's relative to the hydrogen ion activity. There's the technical talk for the day. And to do that, that salt inside has to be plugged in, like plugging an electrical cord into the wall, right, to turn your light on. The same is true. That pH electrode has to ground itself or connect itself to the solution under test. So how does it do that? Well, it has a membrane. That membrane is a porous membrane. It's a reference membrane, and that solution diffuses out, and it makes that electrical connection because it's highly concentrated salt. Salt's very conductive. And then you're able to read your pH. So now when you're storing your electrode, well, that junction's still there, and that solution is kind of under pressure a little bit, and it's going to come out, right? Especially when there's no counter pressure, right? So you're going to get that solution coming out, and what happens? Well, the water dissolves, and what you're left with is the concentrated potassium chloride salts. So that's why you get that crystallization around the electrode, and it kind of gets over the cap or maybe floating in your solution. It's harmless. Basically, it's just the stuff that's in the reference electrode. It's an indication that, like Ryan mentioned earlier, it's an indication folks are not using their pH electrodes, right? Because they're sitting there and they're getting all this salts and they're not being used, right? So, but it ultimately is harmless, and you can rinse it off, recalibrate, you should be fine and good to go.
Right, super. The next question was, going along with our theme of trying to accelerate seed to harvest. Before entering the flowering stage, using a 36-hour dark period, they have noticed that it helps in the transition much quicker. It gets flowering onset. Have you experienced that? Have you tried it?
I have. It is, it can be a little bit harder done in a commercial environment, especially if you're doing any sort of rotations. But it is something that I implement in my garden in either 24 to 36 hours. So if anybody is not familiar with that process, obviously you're going to time that with your photo period of when you want it to, turn on. If you're doing a 36-hour period of darkness and you're wanting your light to turn on at 8 a.m. and run 8 a.m. on to 8 a.m. off, you're obviously the day before you're going to introduce into flowering, you're going to shut that light off at 8 p.m. And then currently, not then turn it on until a full, 36 hours after. I definitely find that will start to set up your flowering a little bit quicker. I do recommend actually a little bit of a heavier phosphorus dose. That can be a little bit tougher to do, especially if you're, utilizing a living soil. Av might have some tricks based on, to, get that little bit of a phosphorus boost. But if you are using any sort of salts, I do recommend doing a phosphorus boost right there the week before, even that day before you go to set them into that 36 hours of darkness.
And Ryan, you do that even though you've got a cooler blue light veg and a warmer red light flower? You still do that?
I mean, that's a little bit unique, I guess, in the sense when you are utilizing, a solution with spectrum control like Elixia, because you can start to control. It's really about those blue to red ratios and how you can start to control some of that stretch. So if you do have any crops that have, any sort of high stretching, you're going to trigger, not only are you triggering these hormonal responses by switching the photo period, but also switching the light. A higher proportion of red, it does induce flowering, but it also induces stem growth. So maybe you want to be able to back off some of that red when you're going into flowering at that very beginning, to not give them that full 100% of that 660 nanometer channel, but yet going in, and increasing that 660 slowly in that first week to really start to mitigate some of that stretching if you have, a sativa type dominant plant that tends to stretch on you. So that kind of works all hand in hand to how you can try to control and slow some of those. But in general, yeah, I'll typically work that 36 hours in right at that beginning of that, before that switch over to the 12-12 period.
Sure. I guess this last question that we have time for, Mike, it says best pH for soils, veg versus flower. And I'm not sure if this means soils as in like a living soil or a soilless mix. But you commented on kind of a hydro soil or a hydro solution where you wanted a pH of between 5.5 and 6.1. Do you have a recommendation around?
I would say again, pH is not as important necessary. It's a great indicator, and it's not as crucial as knowing your alkalinity and the condition of that water you're supplying. Now, we do directly test the soil media, the blocks, whatever type of media you're using, by inserting a direct stick pH electrode. You want to make sure first of all, before we talk about numbers, we want to make sure that that block is moist, okay, or that soil is moist, and you want to establish a consistency. With testing, it's all about consistency. If I'm measuring 2 inches from the stem or 3 inches from the stem, depending on the growth phase of the plant, and 2 inches or 3 inches down, again, depending on the growth phase of the plant, be consistent with where you're testing, where you're monitoring, where you're placing your sensors, because in the soil's alive. I mean, there's a lot of things going on. So you may have radiuses of different results, different readings that may skew a little bit. So it's important that you're consistent with where you measure and test. You have direct EC, you have direct pH. pH, from my experience now, I'm not a grower. I get the water to the plants. From my experience with growers that I've worked with for 20 years, you're looking around a 5.7, 5.8 pH in the soil. It consistently is what they're looking for. Sometimes as high as 6. It depends on the nutrients they're introducing. It depends on the overall alkalinity. But usually I would say 5.7 to 6 in that range is your optimal range for pH of your soil.
Super. What a great way to end. These conversations seem like time flies. I so enjoyed listening to both of you. Thank you so much for sharing your time as well as your wisdom. I look forward this as all of the other grower to grower webinars. They will be, this one's being recorded. It'll be posted on the Heliospectra website. I just want to finish by saying thanks to Ryan Wonko from Heliospectra and to Mike Bogoleski from Hanna Instruments. Perfect example of the type of technical advice and support that these two companies give. Thanks so much for joining us, and we'll see you next time on these webinars.
Thank you.
Thanks a lot, Av. Thanks, Mike. Bye, everybody. Cheers.
Great team, guys. Thank you so much.